You just spent 45 minutes fixing a bug that an AI agent created in 5 seconds. It happens more often than most senior engineers care to admit. You prompt a tool like Claude Code or Cursor to refactor the authentication logic for better performance, and it proceeds to rewrite half your codebase, introducing subtle race conditions and breaking legacy edge cases. This is the illusion of AI speed. We feel productive because the terminal is flying and the diffs are massive, but the actual time to ship, including debugging and verification, is often longer than if we had written the code ourselves. The fundamental problem isn't the AI's capability, it's context drift. The agent loses the way behind the code and starts optimizing for syntax over system integrity. This lecture is about breaking that cycle. By the end of this series, you will learn the exact framework to prevent this black hole of productivity and actually reclaim your time. Pay off right now, you're likely working in a way that feels fast but moves slow, and I'm going to show you exactly how to flip that script by the time we finish today. To survive in the 2026 development landscape, we have to stop treating AI as a sophisticated autocomplete or a chat interface. We need to shift our mindset towards seeing AI as an autonomous unit or a junior engineer that requires a specific delegation framework. Real efficiency isn't about how many lines of code the agent generates. It's about the return on investment, ROI, of your attention. If you are constantly babysitting the agent, your ROI is negative. We are moving from chat-based coding, where you guess and check, to agentic workflows, where you define constraints, set objectives, and let the agent navigate the file system autonomously within a controlled boundary. This transition requires a fundamental change in how you break down tasks. You aren't just writing code anymore, you are managing the execution of complex technical intents. Question, but why does this shift feel so difficult in practice? Let's look at the specific gap between the tool-centric developer and the workflow-centric engineer in the next section. In the field, I see two types of developers using Cursor and Claude. The first is tool-centric. They focus on the features. Did you see the new Composer mode? Or how's the new Claude 3.7 Sonnet model? They generate massive blocks of code, but their repository becomes a graveyard of half-baked features and inconsistent patterns. The second is workflow-centric. These engineers don't care about the tool as much as the system loop. They use agents to explore the codebase, generate unit tests before the implementation, and strictly enforce linting rules within the agentic prompt. The tool-centric gets a 10% speed boost, but the workflow-centric dev achieves a 300% increase in throughput because they've eliminated the review bottleneck. The agentic gap is the distance between having a tool and having a process that allows that tool to run at full speed without breaking the system. Teaser, this gap is exactly why your current AI usage might feel like a toy rather than a professional instrument, and the answer lies in identifying where your time is actually going. Why do most developers experience no net gain in speed despite using the latest Claude or Cursor versions? It's the hidden bottlenecks. The biggest one is the cognitive overhead of verification. If an agent generates 100 lines of code in 2 seconds, but it takes you 5 minutes to read, understand, and verify those lines against your business logic, you haven't saved much. Other bottlenecks include context pollution, where the agent's memory is filled with irrelevant files, and ambiguity costs, where the agent makes assumptions because you didn't define the data structure. To master agentic coding, you must identify which of these is killing your flow. Is it the time you spend correcting the agent? Is it the time spent undoing helpful changes you didn't ask for? Identifying the bottleneck is the only way to build a framework that actually scales. Payoff, identifying the bottleneck is one thing, but how do we actually decide what to hand over? That's what we'll tackle in the delegation decision framework in the next chapter. In the field, the biggest mistake senior engineers make isn't using the wrong tool, it's using the tool at the wrong time. You can't just toss a vague idea at Claude Code or Cursor and expect a production-ready PR. Real-world delegation requires 3 strict criteria: specification clarity, determinism, and scope isolation. If you can't define the input and output types for a function, an agent will fill that vacuum with assumptions that will break your build. For example, when refactoring a legacy React component, unless you explicitly state the prop interface and the expected side effects on the global state, the agent might introduce breaking changes in your Redux store. I've seen teams lose days because they delegated a task that was 20% to code and 80% to unstated business logic. You must ask yourself, is the requirement deterministic, or is it subject to my feeling of how the UI should look? If it's the latter, you're not ready to delegate. But wait, how do we actually measure the context that an agent can handle before it starts hallucinating? Context is the silent killer of AI productivity. We often talk about high context versus low context tasks. A low context task is writing a XOD schema for a JSON object. The agent has everything it needs within the prompt and the file. A high context task is something like integrate this new logging service into our existing event-driven architecture. In this case, the agent needs to know about your Kafka setup, your custom retree logic, and how your internal telemetry library handles OTel headers. Agents in 2026 are smart, but they still struggle to traverse massive, undocumented dependency graphs. If the solution requires knowledge found only in a senior developer's head or a messy Slack thread from 3 years ago, the agent will fail 100% of the time. You must learn to separate isolated algorithms from deep domain logic. This distinction is where the real efficiency gains are made. But here's the catch. Even if the task is low context, there's one more rule you must follow to avoid the debugging trap. I call this the rule of verification. In a professional environment, speed is not about how fast you type, but how fast you can confirm the code is correct. If you delegate a task that takes 2 minutes for an agent to write, but 20 minutes for you to verify, you have effectively slowed down the team. A task is only agent-ready if you can verify its correctness in under 5 seconds, usually through an automated test or a clearly observable UI change. For example, if you ask Claude to refactor the entire auth flow without a robust test suite, you'll spend your afternoon manually testing login, logout, and token refresh. That's a failure of delegation. Instead, you should provide the test case first, then let the agent implement the code to pass it. This test-first delegation ensures that the agent's speed doesn't become your technical debt. So, how do we apply this to a full-scale feature? It comes down to a specific ratio of human to AI effort. To master agentic workflows, you must adopt the 90-10 rule. In this framework, the human developer spends 10% of the time on high-level architecture designing the data flow, defining interfaces, and setting constraints. The agent then handles the 90%, which is the implementation labor. Think of it like a master architect and a group of highly skilled builders. The architect doesn't lay every brick, but they define exactly where the load-bearing walls. If you find yourself writing 50 lines of boilerplate, you're failing the 10%. You should be writing 5 lines of type spec or an OpenAP definition, and then directing the agent to fill in the controllers, services, and DTOs. This approach keeps the human in the decision loop while offloading the execution loop to the AI. By staying at the architectural level, you maintain control over the system's long-term health without getting bogged down in syntax. But how do you actually slice a massive feature request so an agent can handle it piece by piece? The secret to scaling this is atomic ticket breakdown. Most developers fail because they try to give the agent a whole feature at once. Instead, you need to break a feature into atomic tasks that fit the criteria we just discussed. Let's take a user subscription system as an example. Don't ask the agent to build a subscription system. That's a recipe for disaster. Break it down. Step 1, define the Prisma schema. Step 2, implement the Stripe webhook handler. Step 3, create the subscription middleware. Step 4, add the UI toggle in the settings page. Each of these is an atomic ticket with clear boundaries and easy verification. By providing these small, digestible tasks, you minimize the agent's context drift and maximize its accuracy. In the field, this looks like a series of small, rapid-fire commits rather than one giant, messy merge request. Now that we have the decision framework, it's time to move from theory to tools. In next chapter, we'll dive into the specific 2026 workflow using Claude Code and Cursor to implement these atomic tickets in real time. In the field, the biggest bottleneck isn't writing the code. It's the constant switching between the terminal, the editor, and the browser. This is why Claude Code, the terminal-based agentic interface, is a game changer for the 2026 workflow. Unlike standard chat interfaces, Claude Code operates directly within your local environment. It doesn't just suggest code, it executes shell commands, runs your test suites using Vitest or Jest, and fixes linting errors autonomously. For example, when you're refactoring a legacy module, you can instruct it to identify all deprecated API calls and update them while ensuring NPM test passes. It iterates in the background, creating a loop where it modifies, tests, fails, and fixes without you ever touching the keyboard. However, relying solely on a CLI tool for visual UI components is a rookie mistake. But wait, how do we bridge the gap between this headless execution and the visual reality of our IDE? Teaser, the answer lies in the specific synergy between terminal agents and visual composers, which we'll look at next. While Claude Code handles the heavy lifting in the terminal, Cursor AI remains the king of the canvas. In 2026, we don't use Cursor just for auto-completion. We use the composer mode, specifically version 0.45 or higher, for cross-file orchestration. When you need to add a new feature that touches the front-end React components, the back-end TRPC routes, and the Prisma schema simultaneously, Cursor's global context awareness is unmatched. It sees the open tabs and the project index better than any CLI tool. The real power move here is partial acceptance. Instead of accepting a massive AI-generated diff blindly, a senior engineer reviews the composer's multi-file changes file by file, rejecting the hallucinated imports while keeping the logic. This is where you maintain control over the architecture. But this brings up a critical workflow conflict. If you have 2 agents editing the same file system, who wins? Westjian does using both tools simultaneously create a race condition in your local Git state. Let's solve that synchronization puzzle. The most efficient workflow in 2026 is in Claude Vis. It's Cursor, it's a relay race. I call this the draft and execute pattern. You use Cursor's composer to draft the high-level logic and UI changes because you need to see the code structure as it evolves. Once the draft is applied, you immediately hand off the verification to Claude Code in the terminal. Why? Because Cursor can be slow at running large test suites or performing project-wide grep searches. You tell Claude Code, I've just updated the user tier logic in Cursor. Now, your job is to find all edge cases in the existing test suite that I missed and write new integration tests. This hybridity allows you to stay in the creative flow of the IDE while the terminal agent handles the dirty work of validation and regression testing. This handoff is where you gain that 10x productivity boost others are talking about. But wait, this only works if you have a gatekeeper to prevent the agent from shipping garbage. Payoff up until now, we've discussed creation. Now let's talk about the verification gate that keeps your production environment safe. In an agentic workflow, the speed of code generation can be your worst enemy. If an agent generates 500 lines of code across 10 files in 30 seconds, a human cannot possibly review every line for subtle logic errors. This is why you must implement an automated pre-merge validation gate. In the field, we use specialized shell scripts that the agent is strictly required to pass before it even asks for a PR review. Scripts shouldn't just run PM test. It should run static analysis via ESLint, security scanning via Snake or Husky, and even a token cost check to ensure the agent didn't over-engineer a simple solution. You must treat the agent as a junior developer who is extremely fast but occasionally prone to hallucinating that a feature works just because it compiles. If the script fails, the agent enters a self-correction loop. Question, but if the tests pass and the script is green, does that mean the code is actually good? Not necessarily, and that's why the human senior is more important than ever. In the 2026 Agentic era, senior review is no longer about checking semicolons. It's about architectural integrity. When you review an agent-generated PR, you're looking for architectural drift, the tendency of AI to solve problems by adding more code, rather than simplifying existing abstractions. I use a strict checklist. Does this follow our specific clean architecture boundaries? Is there a hidden N+1 query problem that the AI missed because it only looks at the local file? Are the variable names following our domain-driven design (DDD) terminology? If the agent fails these high-level criteria, you don't fix the code yourself. You provide the critique and send it back to the agent. This is human-in-the-loop (HETL) at its finest. You are the architect, the AI is the mason. Teaser, but what happens when the mason gets stuck? Sometimes the agent enters a loop of fixing one bug, while creating another. Let's look at the emergency recovery strategy. The most frustrating part of agentic coding is the hallucination loop. This is where an agent fails a test, tries a fix, fails again, and starts hallucinating libraries that don't exist. When this happens, you have to break the loop manually. In the 2026 workflow, we use a clarification reset. You stop the agent, clear its context window if possible, and provide a hint, usually a link to documentation or a specific code snippet from another part of the codebase. You are essentially recalibrating its internal map. Visualizing this loop helps you recognize the signs of agent fatigue or token exhaustion early. If it fails 3 times on the same issue, it's not an AI problem, it's a prompt or requirement clarity problem. By mastering this recovery loop, you ensure that the workflow never grinds to a halt. In the next chapter, I'm going to take you into the trenches with real battle stories where these workflows were tested to their breaking point in production environments. Bridge, get ready for battle stories from the frontline, where we'll see how these agents handled a real-time system failure. In the field, we often see a catastrophic failure I call context amnesia. Imagine you are using a 2026-era agent like Claude Code or a high-end cursor agent to refactor a complex authentication module. You feed it the entire project folder because you think more context is better. But suddenly, the agent deletes several critical export functions and breaks your CI/CD. Why? Because the context window became so cluttered with logs, build artifacts, and irrelevant test files that the model hit a retrieval fatigue point. It hallucinated that those missing functions were redundant because they weren't explicitly mentioned in the most recent 20,000 tokens of the active prompt history. This isn't a model failure, it's a management failure. When the context window is flooded, the agent loses its semantic anchor and starts making dangerous assumptions to fill the gaps. I've seen senior developers lose hours of progress because they didn't realize the agent was working with a truncated, distorted view of the system architecture. The noise drowned out the signal, leading to a silent but deadly deletion of production logic. This is the first lesson of agentic coding. More context often equals more noise, not more intelligence. But does this mean we should just give the agent less information? Not exactly. The secret lies in how you filter that information. Question, is the solution just to starve the agent of data? I'll show you why that is equally dangerous in the next scene. To avoid the disasters we just discussed, you must transition from being a task giver to a context librarian. In the field, the dump everything method is a rookie mistake. You drag and drop your entire documentation folder into Cursor and hope for the best. This results in the agent mixing up V1 and V2 API specs, or trying to use deprecated libraries that are still mentioned in old README files. The curator method is what experts use. You must provide a source of truth hierarchy. Use features like cursor rules or Claude's project knowledge to explicitly pin the current architectural standards. For example, instead of saying fix this based on the docs, you provide a structured prompt using API VBSpec and as the primary reference and ignoring any files in the legacy directory, refactor the login handler. You are essentially pruning the search space for the agent. By isolating the agent's focus to the relevant schema and the specific source files, you drastically reduce the chance of hallucination. It's about creating a clean room environment for the AI to reason within. If you don't act as a librarian for your agent, you are essentially asking it to build a house using a pile of mixed trash and treasure. Payoff. Now you know how to feed the agent, but what happens when the agent's perfect output is actually a ticking time bomb for your codebase? The most dangerous feature of 2026 agentic workflows is the accept all button. When an agent like Claude Code generates 500 lines of code across 10 files and all your local tests pass, the temptation to merge immediately is overwhelming. However, this is how AI spaghetti code is born. I've seen projects where technical debt didn't just grow, it spiked by 200% in a single month because developers stopped reading the code. They became reviewers of results instead of reviewers of logic. The test passed because the agent wrote the tests to match its own flawed logic. The code looks clean because the formatting is perfect, but the underlying architecture might be fragmented, creating a nightmare for future scalability. You might find memory leaks that only trigger in production or subtle race conditions that the agent's simplified test suite couldn't catch. Blindly trusting an agent's merge request is exactly like letting a junior developer push to production without a PR review just because they type fast and use a linter. We are seeing a new era of shadow debt where the code looks like it was written by a senior, but functions like it was written by someone who doesn't understand the long-term system constraints. Teaser, this leads to a critical question. How do we maintain speed without sacrificing the soul of our architecture? The answer lies in the senior's guardrail checklist. To combat the unverified merge nightmare, every senior engineer must enforce a guardrail framework. You must treat every agent output as a draft proposal, never as a finished product. My personal rule is the 3-tier sanity check. First, look at the logic delta. Did the agent solve the problem using the most direct paths, or did it over-engineer a simple utility? Agents love to add complexity. Second, check for context consistency. Does the new code follow the specific design patterns and naming conventions of your existing repo, or did it default to general internet standards? Third, and most importantly, perform negative test analysis. Agents are great at the happy paths, but they frequently ignore edge cases like network timeouts or invalid database states unless explicitly told. You must manually inspect the diff for these gaps. In 2026, your value as an engineer isn't in writing the code, but in the judgment call of whether that code should exist at all. By applying these strict rules, you ensure that the AI remains a tool for productivity rather than a factory for legacy code. Bridge. Now that we've covered these battle-hardened lessons, we're ready to move to Chapter 5, where we will formalize these to a set of best practices and anti-patterns that you can take back to your team tomorrow. Many developers hit a productivity plateau with agentic tools because they fall into the prompt spray and pray trap. They provide a vague instruction like fix all the bugs in this folder and hope the agent figures it out. This is a massive anti-pattern in 2026. In the field, we see this leading to context poisoning where the agent hallucinates because the task boundary was too wide. Another common mistake is the lazy pilot approving code changes without running tests or even reading the diff. These habits don't just create technical debt, they create AI-generated debt, which is much harder to untangle because no human actually understands the logic flow. To succeed, you must move from bulk prompting to incremental verification. Treat your agent like a high-speed junior developer who needs clear, small tasks and constant feedback. If you don't define the boundaries, the tool will eventually break your architecture. But even if you avoid these habits, your code might still be unreadable to the very agent trying to help you. Let's look at why your naming conventions are now more important than ever. In the era of agentic coding, clean code isn't just for human readability anymore, it's for agentic context retrieval. Tools like Cursor and Claude Code rely on RAG and semantic search to find the right files. If your functions are named process 1 or handle data, the agent's embedding search will fail or, worse, pull in the wrong context. Modern senior engineers use semantic architecture designing modules so their names and structures explicitly describe their intent to an LLM. Think of your codebase as a map for the agent. If the map is blurry, the agent gets lost. Modular design with clear boundaries allows you to use the dimension or file attachment features much more effectively. You want to reach a state where you can say fix the auth logic in the user service and the agent knows exactly where to go because the naming is unambiguous. This reduces token waste and prevents the model from hallucinating logic that doesn't exist in your stack. Does this mean we are just becoming glorified reviewers? Actually, the role is shifting to something much more strategic, which we'll define in the next section. The developer's role is fundamentally shifting from writer to editor-in-chief. You are no longer the one typing out every for loop or boilerplate API call. Instead, you are the architect and the final gatekeeper. Your value now lies in your ability to decompose complex business problems into high-confidence instructions and to spot subtle logical flaws in AI-generated PRs. This requires a deeper understanding of the system as a whole. You need to know the what and why better than ever, even if the agent handles the how. We've seen that the most productive engineers in 2026 aren't the fastest typists, but the best reviewers. They understand that every line of code the agent writes is a liability until it is verified. To thrive, you must master the decision framework of what to automate and what to hand code to maintain the integrity of your software. We've covered the do's and don'ts, but how do you actually turn this into a daily habit? In the final chapter, it'll give you the exact checklist to start your next project with an agent-first mindset. Theory is great for a coffee break, but your IDE doesn't care about theory. Within the next 24 hours, you need to stop playing with the chat and start building your delegation infrastructure. First, configure your cursor rules or local agent configurations not with generic instructions, but with your specific project's architectural constraints like how you handle state management or error boundaries. Second, you must integrate a CLI-based agent like Claude Code into your terminal workflow. The gap between thinking in the IDE and executing in the shell is where most productivity dies. Finally, start a delegation failure log. Every time the agent hallucinates or loops, don't just fix the code, write down why it failed to understand the context. Was it missing a clear README? Was the file structure too nested? This is how you build a professional-grade environment that actually saves time instead of just generating more boilerplate you have to debug. If you don't set these boundaries today, you will remain a highly paid debugger for a mediocre AI. Wait, setting up the tools is only half the battle. The real differentiator in 2026 is how you evolve your own role as a decision maker. As we wrap up this journey, remember this. The arrival of agentic coding doesn't make the senior engineer obsolete, it makes the unthinking developer obsolete. In the next few years, the market won't pay for the simple ability to write a React component or a Serial API. Agents do that for pennies now. The real value has shifted entirely to intent engineering and architectural oversight. You are no longer just a builder, you are the conductor of an orchestra of autonomous agents. The best developers I see in the field today are those who treat AI as a junior developer with infinite speed but zero common sense. They focus on the why while delegating the how. If you master this mental shift, you won't just survive the AI transition, you will lead it. This lecture was just the starting line. The race starts the moment you open your terminal today. I look forward to seeing the complex systems you will build when you finally stop fighting the tools and start leading them. Thank you for joining this masterclass, and remember, the most powerful tool in your stack is still the decision-making framework between your ears.